Today we are going to continue factoring, so we're going to be using the same process, same recipe for factoring like we've been, but today we're going to be looking at the special products. And if you remember when we did the distribution, we also spent some time looking at some special situations. So actually I want to start, let's just go right down to that first example, x squared minus 81. And we need to factor it. So notice we're used to something that looks like x squared, say, plus some number x plus some number. In other words, we have three terms, but now we only have two. Well, it's the same idea. It's almost as if it says this, like there's no x's, right? So there's 0 x's. So same idea, we want two numbers that multiply to give us negative 81, but will combine or add to be 0. In other words, there is no middle term. And so I think we can all agree that those two numbers for negative 81 would be 9 and negative 9, because 9 times negative 9 is negative 81, but 9 plus negative 9 is 0. And so that's it. It's x plus 9, x minus 9. And if you remember back earlier in the chapter when we were foiling and distributing these parentheses, that was a special product, right? That when we had the same thing times itself, one positive, one negative, we remember our answers looked like that. They were special. And so this is a special situation that's really easy to remember because it stands out. No middle term. When there's no middle term, we know we're going to have the same parenthesis times itself, one positive, one negative. You try the next two, pause it, and then push play when you're ready to check. So this next one, same thing, multiply to be negative 49, but it's going to add to be 0. So that's going to be x plus 7, x minus 7. Now this last one's a little tricky. It's still the difference of two squares, and so we have to think, oh, 3x plus 10, 3x minus 10. In other words, it's still a perfect square, difference of two squares, but we have to think 3x and 3x, 10x and 10x, or 10 and 10. Now the last special product is the perfect square trinomial. And that perfect square trinomial was when we had one parenthesis squared. It might have been like x plus 4 squared would be an example. And remember, that meant this, which if we multiply it out, it does equal that. And so we can see that it's 4 times 4 equals 16, and 4 plus 4 equals 8. So it's the same number for both parentheses. In fact, they're exactly alike. But these, they're not as easily identifiable. And so we might end up going about it in our usual way. That is, what two things multiply together to give us 16, but combine to give us 8. And only after you do it, you might realize, oh, yeah, it's the same thing. Same thing here. Multiply to give 64, but combine to give negative 16. Well, that would be negative 8 and negative 8. This last one, same thing. Multiply to give us 100, combine to give negative 20, minus 10, and minus 10. So the last section here is about solving. And remember, when we solve, it has to equal 0 in order to set our factors equal to 0. So the first thing we need to do to this one is move those things over to the other side. So this is going to be y squared minus 12y plus 36 equals 0. Now we can factor it. And we're going to get y equals 6. Oop, don't have to write it twice, do we? Y equals 6. Remember, if the parentheses are the same, we get one answer. For this last one, we're going to subtract 49 from both sides, and we're going to get 4x squared minus 49 equals 0. Now this is going to be 2x minus 7 and 2x plus 7. And for this one, we're going to set each parenthesis equal to 0. And so we're going to get x equals 7 halves, and the other one will be negative 7 halves.